All right, so the first one says, classify these words into two groups and explain your reasoning. Page 288 in your textbook should help you some. Basically, I want the 6 terms divided into 2 groups, each group with 3 terms. All right, raise your hand if you think you know how to divide them. Okay.
Would it be brightness, color, and temperature, and luminosity?
Color and temperature go together, but they don't go with brightness. Look at page 288, your chart. You said color and temperature, and what else goes with that? Spectral class. Okay, so those 3 get grouped together, and then brightness, magnitude, and luminosity get grouped together. Okay, so the ones that I did in blue, spectral class, color, and temperature, those all have something to do with how hot a star is, because they're all tied together. And then the ones that I did in pink, those all describe how much energy or how much light a star is emitting, or how much light a star is giving off. The reason why we have stopped to take a look at this is because if you guys have noticed in lesson 3, we start looking at what's called the Hertzsprung-Russell diagram. And the Hertzsprung-Russell diagram is just basically a graph. On the y-axis of that graph will be one of these 3 things. They all basically mean the same thing, but sometimes they'll put brightness, sometimes they'll put the word magnitude, sometimes they'll put the word luminosity. Just depends. But they all mean the same thing. They're going to have something about brightness on the y-axis, and one of these 3 things, something about how hot the star is going to be on the x-axis. Sometimes they'll put spectral class, sometimes they'll put temperature, sometimes they'll put color. It just depends on how they're making the graph and who's making it. Has everybody got that? Okay, so let's move down. Number 2 asks you to define absolute magnitude and apparent magnitude. Who's got absolute magnitude? Go ahead.
How bright it actually is.
Okay, so absolute magnitude tells you how bright a star actually is, or you can say how much light a star is actually giving off. What about apparent magnitude? Somebody? Yeah.
How bright it seems.
Yeah, good. That's how bright it seems to us from here on Earth. And that's going to have something to do with just how far away that star is. I mean, it also has to do with how much light it's actually giving off. But let me get those 2 definitions up. Okay, let me get that shifted over. All right, so absolute magnitude tells you how bright a star actually is or truly is, meaning how much light is it actually giving off. And apparent magnitude is how bright it seems to be, and that's going to depend some on distance. Then we go down and there's some true-false statements about galaxies. True or false, a galaxy is a large collection of stars, gas, and dust held together by gravity. What do you guys think? That's true. Okay, so circle that as true. Next statement, galaxies contain most of the matter in the universe. True. What's between galaxies, guys? Voids, like lots and lots and lots of emptiness. So basically your matter is clumped together in galaxies, and galaxies are separated by lots and lots of nothingness. 3 types of galaxies are rectangular, spiral, and round. True or false? False. Have I ever given you a description of a rectangular galaxy? No, that's not a galaxy type. Spiral is a galaxy type. But what are the other 2 main varieties? Irregular and elliptical are the other 2. Very good. And then last one kind of got cut off, but it says our solar system is in the center of the Milky Way galaxy. True or false? False. Our solar system is not in the center. Our solar system's not out on the very, very edge either. It's kind of halfway between the center and the edge. Okay? Okay, so your page should look like that so far. Everybody got it? All right, let's go to the back. All right, number 4, page 288 might be very helpful. The coolest stars are spectral class what? M. Good. And what color do they appear?
Red.
They appear red. Okay, next we're going to look at star N and star W. Try to get all of this in here. Star N has the following characteristics. Its apparent magnitude is 2.5, absolute magnitude is negative 0.2, its color is white, distance 150 light years. Star W has the following characteristics. Apparent magnitude is 0.1, absolute magnitude is 3.2. Color is orange, distance 25 light years. Okay, down at the bottom, it's asking for you to compare star N and star W. There are basically 4 statements that you can make. You can make a statement about apparent magnitude, you can make a statement about absolute, you can make a statement about its color, you can make a statement about its distance. Anybody want to give it a go? Let's start with something easy. Let's start with distance. Star blah 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 is, I don't know, closer, farther than. Okay, do what?
Star N is farther away from Earth than.
Okay, you can say star N is farther away than star W. Conversely, you could say star W is closer than star N, but same thing. All right, let's make a statement about the color and or temperature. Anybody got a guess? Somebody different this time?
Star N has a greater temperature.
And how do you know? That is correct. Star N is hotter. How do you know?
Because its spectral class is A,
Uh-huh.
and its temperature is 75,500 to 100.
And how do you know that that's its temperature? What was on this page that helped you know that?
Its color was white.
Okay, so the color corresponds to a certain temperature. White corresponds to spectral class A and a higher temperature than spectral class K, which is orange. Does that make sense? So you can write star N is hotter than star W, or you could write star W is cooler than star N, either way. Okay, next thing I want you to look at is apparent magnitude. Which one of these stars is going to appear to be brighter? Yes, ma'am. Okay, and how do you know? Okay, the smaller number means brighter, and W has a smaller number. So W appears brighter than N. Okay, and then look at absolute magnitude, the amount of light that's actually being given off. Who's actually brighter?
Star N is actually.
Okay. So star N is actually brighter because its absolute magnitude reading is a smaller number than star W's absolute magnitude reading. So our final statement is going to be star N is brighter than star W. Okay, are we good so far? Are we good? All right, let's go down to the last little bit, number 6 and 7. All right, in the table are the common names and then the scientific names of these stars down here, and then apparent magnitude of those stars and their distances are also listed. This is the Big Dipper, which is a well-known part of the constellation Ursa Major. It looks like, well, I mean, it looks like a soup ladle, basically. So you've got 7 stars making up the cup and the handle of the dipper. And number 6 asks, are all stars in the Big Dipper the same distance from Earth? How do you know? I read the chart, Miss Goff. Yeah. They're not all the same distance. The one that is closest is Megrez, I guess, at only 58 light years. And the farthest away is Dubhe, Dubhe, whatever, at 124 light years. Okay, so they are not all the same distance. When you look up at these at night, you can't tell which ones are further away because it looks like it's just on like a two-dimensional canvas or whatever. Okay, but they're not all the same distance from Earth. All right, number 7 asks, which star do you think has the brightest absolute magnitude?
Would it be the first one? Because it has one of the brightest apparent and it's farther.
Yes. So she asked, would it be the first one? And the answer is yes. Dubhe, W, whatever. It's got the smallest number for apparent magnitude, which means that it appears bright. And if it appears bright and it's the furthest away, then we know that it actually has to be giving off a lot of light. Okay? So which one's going to have the brightest absolute magnitude? That's going to be Dubhe, or Alpha Ursa Major. Because it's bright and it's still bright even though it's far away. It's like if I gave all of you guys different brands and different types of flashlights and had you stand all at different distances. If somebody had a really, really bright flashlight and they were the ones that were standing the furthest, and I'm looking around and I notice that they, to me, seem really bright, well, that's because they really, really have a bright flashlight. Because if they can appear bright even when they're standing far away from me, then they're really giving off a lot of light. Does that make sense to you guys? Okay, so let me just clean this up and put some answers down. Make sure you guys have everything.